All right. Hello, everybody. So here's your assignment for today. First, I'm going to go over the homework, and then I'm going to introduce applying bar charts to momentum and ask you to do a few more of those on your own. So first, let's go over the homework. So in 211, right, what we're going to do is we're going to create a little diagram, the before, the after, and then analyze, right, find the momentum, the total momentum, and then from that, we can solve back and find what the final velocity should be. Okay. So I'm going to set this up and just draw it all out and put all the information in there. So now I have it set up with the before, the after, both of the balls and the masses, the velocities, and then the momentum of each of them. Now, what do I know? The total momentum before has to equal the total momentum afterwards. So I can set up an equation, right? It's actually like this plus this equals this plus this. What do we have now? That's an equation. And there's one variable, there's one unknown, and we can solve for that. So let's do that. So there's the algebra. And then I wrote v 0.2 f because that's the final velocity of the zero point 0.2 kilogram ball. Okay. So that's the kind of uh, thing we're doing here. So now, different situation. We have some fireworks. This thing is moving along at a certain speed, and then it explodes and it breaks into two pieces. Okay, so that total momentum that it has initially, that will be the total momentum of the two pieces at the end. So let's do this. Well, the way that I find the mass, I know the total mass is zero point 0.4 kilograms. Now, the other piece that we're finding the velocity for is going to be 90% of zero point 0.4. So it's actually zero point 0.9 times zero point 0.4, which I think should just be 0.36 kilograms. And then 10% of zero point 0.4 is just 0.04, right? You could do 0.01, 10%, or rather 0.1, 10% times zero point 0.4, and that gives you 0.04. I do the same thing I've done before. Okay, so now I've got the masses, the velocities, at least the ones that I know, and the momentum. And I have this little equation because I know that total momentum before is equal to the total momentum afterwards. This is what we call conservation of momentum, by the way. Now I can solve for V. Let's do it. So the final momentum, or the final velocity, is negative 2.2. That's the final velocity of the zero point 0.9, or the 90% piece. So what does that mean? It means it's moving backwards. So it's moving along and it breaks apart. One part flies off and the other part actually goes backwards. For 2.13, we're just asking which of these has the biggest momentum. And so what you do is you just calculate the momentum for each of them, mass times velocity, and then find which one has the most. So when we calculate the momentums, that's what we get. By the way, for C, you have to convert from grams to kilograms. Okay, now let's take a look at um, using bar charts, what we learned with money, and now applying it to momentum. Okay, so we're on section 3.5. And going back to the experiments from activity 2.1 or 2.3, forget what it is, but it has the same data that we have here. And we're going to see if we can create a bar chart for this. Okay, the bar chart actually comes right from the drawing. We already did the drawing in the sketch. So let's redo that and then see how we can apply it to the bar chart. So when I look at this, with the money, I had different forms of money. What I have here is different objects that can have momentum. So card B can have momentum, card A can have momentum, etc. And so the equation I'm going to write at the top is going to have to do with momentum. And it looks like this. So here is the momentum of cart B initially, and the momentum of cart A initially, plus any big changes in momentum to the system, right? If there are outside forces, outside things acting and changing the momentum, taking away or adding, then that's what would go there. And then the final momentum of cart B and the final momentum of cart A. The only reason I'm putting B first instead of A is because in my diagram, that's what I have. I have B on the left and A on the right. So initially, cart B has no momentum. So just put a 0 there. Cart A has 0.14. And I can make that whatever height I want here. So I'm just gonna go up to about here. I'm gonna say this is 0.14. There are no changes in the overall momentum. It's the same before and after. And then afterwards, oh, actually, do I want to make this negative? You know what? Let's just do it like we did before and make it positive. By the way, you may notice I did change um, the masses from 200 grams to zero point 0.2 kilograms. We've established that kilograms is the standard unit for momentum, so that's what I put in there. Okay, so we're just going to make this, we're going to make left positive for this, the way we had before. We're going to keep that the same. And so this is also 0.14, and this is 0. Okay, and our equation works, right? Look, 0 plus 0.14 plus 0 equals 0.14 plus 0. This equation is true. And it works the same way analogously from what we were doing with the money, but now we're just applying it to momentum. And the bar chart gives us a way of visualizing the momentum. All right, momentum is a little hard to visualize because it's velocity, it's mass, it's this combination of things. And then it's strange how it can stay the same after a collision and all that stuff. And so we have the bar chart to help us visualize things and organize our thoughts. All this is about organizing our thoughts, right? We've got all this data, all these numbers. And so we're organizing them and keeping them neat for ourselves so we can think in an orderly way about it. Okay, so I've done A. Your assignment for today is to finish B, C, and D. You're creating bar charts for these other three collisions. So that'll be due on Monday, and hopefully I'll see you then. Thanks for watching. Don't forget to like and subscribe.